So we're starting into chapter 2, talking about graphs, lots of different kinds of graphs. We're going to start with some pretty simple concepts here, the distance formula and the midpoint formula. So we're just going to work on using the distance formula. And using the midpoint formula. So this section is going to go really quickly. Just a reminder about a lot of things you already know about the X, Y coordinate system where we have two number lines. The horizontal one we label X on the right, and the vertical one we label Y at the top. And we call this a rectangular coordinate system. It's also called a Cartesian coordinate system. And this is after the French mathematician Descartes. So we need some definitions. The x-axis we're going to call the horizontal axis, the y-axis the vertical. The origin is the point 0, 0. And we say this is the positive x direction and this is the positive y direction. And as I said, this is also called the Cartesian plane. Plane goes infinitely in two directions. So points are located using two coordinates, like A, comma, B. And plotting a point means put a dot at the location of the two coordinates. And we have four what we call quadrants. So they're numbered quadrant 1, where x is positive and y is positive. Quadrant 2, x negative, y positive. Quadrant 3, x negative, y negative. And quadrant 4, x positive, y negative. And for whatever reason, somebody long ago decided we should use Roman numerals for the quadrants. So that's what we do. So objective 1 is going to be to use the distance formula. And the distance formula says if we have 2 points in the coordinate plane system that have coordinates x1, y1, and coordinates x sub 2, y sub 2, then if we want to find the distance between these 2 points, what we really do is imagine a triangle that connects the 2 points, where the 2 points form the hypotenuse of a right triangle. And then hopefully you've learned somewhere long ago that in a right triangle, if you find the length of one side and square it, plus the length of the other side and square it, you'll get the length of the hypotenuse squared. So this length of the hypotenuse is we're calling the distance between point 1 and point 2. So that's the notation we're using. So the formula is, if I want to find this horizontal distance, it is x sub 2 minus x sub 1, or the other way around, as we talked about the other day, that as long as you're squaring, the order of the subtraction doesn't matter. And then it's plus y2 minus y1, quantity squared, the square root of all that. So it's basically the Pythagorean theorem. If you call this side A and this side B, you'd have a squared plus b squared is c squared. And the order doesn't matter because x sub 2 minus x sub 1 squared equals x sub 1 minus x sub 2 squared. We tried this out and figured out that sure enough, as long as you're squaring, the result is the same, whatever the order is. And then also the order of these two terms doesn't matter because there's a plus. So here's the illustration that goes with the theorem. And then we'll just practice finding the distance between 2 points. And then we can use this idea to solve other problems. So this one says to plot each point and form a triangle and show that the triangle is a right triangle. Well, the way that you show that a triangle is a right triangle, if you don't know, is that you show that a squared plus b squared equals c squared, because the theorem says if a squared plus b squared equals c squared, then the triangle is a right triangle. That's the Pythagorean theorem. So I'm going to ask you to plot these points on a coordinate system, -2, 5, 12, 3, that's A, B, and then 10, -11. It's point C. So the idea is to imagine a triangle with these 3 points and then see if you can figure out if it's a right triangle. And you have a homework problem like this, but we'll work on this in class together. And then objective 2 is use the midpoint formula. And using geometry, which you may or may not have, and it's fine either way, it can be proved that if you want to know where the middle of a line segment is, where this is point 1 that has coordinates x1, y1, and this is point 2 that has coordinates x2, y2, then the midpoint is the mean or the average of the x-coordinates as the first coordinate of the middle, and the mean or the average of the y-coordinates as the y-coordinate of the point in the middle. So we'll look at this problem where we have the point 2, -3, so that's point 1, and then 1, 2, 3, 4, 1, 2, that's point 2, and we'll use this formula to find the point that's in the middle of those two. And that's all there is for this section.